This is Miss Humbert here. Today we're going to do Unit 5 Notes 3. So we're going to start talking about similar triangles. So we're going to apply a lot of what we did yesterday, but there's some special properties that come to triangles that we can kind of use almost as shortcuts so that we can get going and calculate out less as opposed to with an entire polygon. So let's take a look at some properties. So a lot of these we kind of use to prove that triangles are congruent also apply to proving that they are similar. So if two angles on one triangle are congruent to the other triangle, then the two triangles are similar. So if we know angle A, if we know that angle A is congruent to angle F, this is working well, angle A is congruent to angle F, and we know that angle B is congruent to angle G, then we can confidently say that the triangle ABC is congruent to the triangle FGH. Okay, so all we have to know is that two triangles are congruent, or two angles are congruent, then we can prove that the two triangles are similar. Alright, so let's take a look at number 1. So determine if they are if they're similar. If they are, write the similarity statement. If they're not, explain your reasoning. So here we have 57 and 48. Okay, so we know that triangles have to add up to 180. So you can take 180 minus 48 minus 57. Because right now we don't have that two angles are congruent in what we're given. That doesn't mean though that they're not similar. When you subtract that out, you end up getting 75. So when I subtracted that out, I ended up finding out that this side was actually 75. So now I have two angles that are congruent. So that means I can say that they are similar. So now I need to write out my similarity statement. So triangle JKL. Now this also has to be 48 because we know that that will make it add up to 180 by this guy right here. So first, when we write out our similarity statement, we need to write out the 48 letter, which is Q, and we should have a triangle in front there. And then we want to do our 50s, then for K our 75, which is P, and then M. So you need to watch where you line up your letters because you want to make sure you line up those corresponding angles. Let's take a look at this one. So we have two parallel lines. That's what those mean. And then we have our transversal. So here we have alternate interior angles. So we know that those have to be congruent. Also, we know that vertical angles have to be congruent. So we kind of use those properties of stuff that we learned in Unit 2 to show that we have two congruent angles here. So let's go ahead and let's write out that similarity statement. So we have triangle. Let's do R, S, X. And now we want to figure out that that's going to be similar to, well, R is actually going to correspond with W because they both have the arc. Those are the alternate interior angles that are congruent. S is congruent to S. And lastly, we know by default T is going to be congruent to X. So here is our similarity statement for part B. Let's take a look at another theorem. Another theorem that we use is if corresponding side lengths of two triangles are proportional, then the triangles are similar. So if they're all proportional, then it's similar. So, for example, if we just go by our colors here, if MP divided by JK is equal to QP divided by LK is equal to ML, sorry. Want to keep that first triangle on top. To M, so MQ is similar to JL. Okay, if all of those are true, then we can say that triangle JKL is congruent to triangle MPQ. Again, you want to keep those corresponding angles all lined up. So let's go ahead and let's apply that property. Let's take a look at number 2. So for number 2, it says determine whether the triangles are similar. If so, write the similarity statement and explain your reasoning. So all we're worried about is the sides. Okay, so what I'm going to do is I'm going to line up the sides. I'm going to take my smallest side of the first one, which is 6, and put it over the smallest side of the second one, which is 4. So I can cross those out. Then I'm going to take my middle side of the second one, or the first one, which is 7.5. That goes on top. put it over the middle side of my third one, which is 5. Then I'm going to take the largest side of my first one, put that on top, and put it over my largest side of my second one. So now I want to see if these decimals, these ratios, equal each other. So 6 divided by 4, that's going to give me 1.5. 7.5 divided by 5, well, that's going to give me 1.5. So far, so good. I just need to track that last one. Then 9 divided by 6, 1.5. Good, so that works. So yes, it is proportional, so that makes it similar. Now we need to line up our triangles. So I'm going to start and I'm going to do triangle A, B, C. So that's going to be similar to triangle. Now, AB was the longest side, so I need to put the longest side there. So that means I need to put that equal to DEC. That way, AB corresponds with DE. BC corresponds with EC, and so forth, like we use to do our ratios up top there. Let's take a look at another example using the side angle side similarity theorem. So if two sides of one triangle are proportional to the lengths of two sides of the corresponding triangles of the other and the included angles are congruent, then the triangles are similar. So notice we're going to be looking at this side and this side and this side and this side because the angle that's congruent is sandwiched in between them. It has to be sandwiched in between them. So if we know that RS is congruent to XY, or sorry, it's not congruent, is proportional the same way as ST is proportional to YZ. If those two proportions are equal and angle S is congruent to angle Y, then we can say that angle SRT is congruent to YXZ. Again, notice I lined up S with S, R with R, T with T, or Z, sorry. R with X and T with Z. So we line up all of our corresponding angles. So that's the side angle side theorem. So let's go ahead and let's take a look at it in terms of similarity. Determine whether the angles are similar. If so, write the similarity statement and explain your reasoning. So for this, remember that vertical angles are congruent. So I have a side, angle, side, side, angle, side. Now I can't just assume that this works because I have an angle sandwiched between two sides. I know the angles are congruent, I have that done, but I have to check to make sure the sides are congruent. So proportional, sorry. So I'm going to take the smallest side, which is 10, and put over the smallest side of the second triangle, which is 20, and see if that's proportional to the smallest side of the first triangle divided by the larger side of the second triangle. So now let's go ahead and let's see if that's true. 10 divided by 20 is 0.5. 11 divided by 22 is 0.5. So they're proportional, so I can say yes. But now I need to write out my similarity statement. So I have triangle. Now I'm going to do T, W, Z is similar to triangle. Now, T to W is the short side. So Y to W is the short side of the other one. So Y and T need to relate, and W needs to relate to W, which means my X needs to come last. So that's your similarity statement, and that was by the property of side angle side. Next, let's take a look at this one. So we kind of have a triangle within a triangle. So I have a smaller triangle, and then that's 10 and 12. Now they're both going to be sharing that angle M. So that means that angle M is going to be congruent for both of my triangles. So I'm just writing them out separately. Now this whole length is going to be 10 plus 15, which is 25. So right now I'm drawing out this whole big triangle right here. But M is an angle in common for both of them, so we know it's going to be congruent. To get the other side, 12 plus 18 is going to give me 30. So now I have my two triangles. We know the angle's congruent. We need to check the sides are proportional. So 10 should be proportional to 25, as 12 is proportional to 30. So let's go ahead and check that. When we do 10 divided by 25, we end up with 0.4. Is that equal to 12 divided by 30? Why, yes, they're both 0.4. So now I know that my two sides are proportional. So that means I have two proportional sides and the included angle is congruent. So I can say yes, they are similar by side angle side. So let's write out that similarity statement. So for the first triangle, if we scroll back up here, we have NMP. So I'm going to write it out that way first. So triangle NMP is similar to triangle, now we're going to go RMS. Again, making sure those corresponding sides line up. All right, let's take a look at number 4. So for number 4 in that figure, that angle ADB is a right angle. Which of the following would not be sufficient to prove it? Okay, well let's take a look at letter A. So AD is congruent to BD. So let's go ahead and let's write out the triangles that we have here. So we have one like this, and then I'm going to write this one this way. So D is our right angle, B is our point, and A, and B is our point up here, and this is C. So in theory, we want AD to be proportional to BD and BD to be proportional for CD. Well, that seems like it would work. For this one, we want AB to be proportional to BC and BD to be proportional to CD. Okay, so when we take a look at that one, oh, sorry, this one was AD. I apologize. So I was doing the wrong one. So B works, okay? Let's take a look back at A again. So taking a look at A, it gives us that AD, I'm just going to do it in a different color so we can see it here, it gives us that AD is proportional to BD and BD is proportional to CD. So that might work, okay, because that included angle is a right angle. Screwed this up again. I'm sorry, guys. Goodness gracious, I'm losing my mind. Okay, so A works. Let's take a look at B. So taking a look at B, we know that AB is congruent to BC and BD is congruent to CD. Well, we know nothing about this angle. We don't know that that included angle is congruent. So B cannot work. Sorry, that was a little bit confusing. Let's take a look at number 5. So for number 5, we have two parallel lines. Okay? So that also we know that this angle in here is congruent. Okay, likewise, we know that this, because of transversals, is congruent to this. Okay, so because of alternate interior angles. So then I can use 4 over 10 as a scale factor. Because then we'll have side, angle, side. And then we're going to go ahead and we have our smaller one over this guy. So now we can go ahead and we can solve this using cross multiplication. Okay, so set this up. So then we have 4 times 2x plus 10 is equal to 10 times x plus 3. So I'm going to give that a second to catch up. So for the sake of time, what I want you guys to do is to go ahead and solve that for x. So go ahead and solve that for x so I can get the next one set up for you. So taking a look at number 6. So again, given that these two are parallel, okay, if those two are parallel, that makes this and this transversals, which means that this angle is congruent to this angle by alternate interior angles, and this angle is congruent to that angle by alternate interior angles. So let's take a look at where we have a side, an angle, and a side. So this is the side we want to know. So we have a side, an angle, and a side. Over here, a side, an angle, and a side. So let's go ahead and let's set up our proportions. So 40 is going to associate with our x. So we have 40 over x. And then our 50 is going to associate with our 200. So we're going to have 50 over 200. So I'm going to go ahead and have you guys solve that proportion on your own. Make sure you label your answer meters. That concludes your note video day. Make sure you show me a completed note sheet. Thanks for listening.